So the use of fission in nuclear reactors. Electricity generation uses the same basic process as electricity generation from fossil fuels. Steam turns, so what actually happens during this process is steam turns in a turbine that turns a generator that can generate electricity, and nuclear power plants use a radioactive isotope known as uranium-235, which is its fuel source. So radioactive decay occurs when a parent radioactive isotope emits alpha or beta particles or gamma rays. Uranium-235 also undergoes fission. So fission exactly is the nuclear reaction in which a neuron strikes a relatively large atomic nucleus, which then splits into two or more parts. So fission releases an additional neutron and energy in the form of heat, and additional neurons can promote more fission reactions that leads to a chain of reactions that gives off immense energy heat. This heat is used to make steam, and 1 gram of uranium-235 contains 2 to 3 million times more energy than 1 gram of coal. So uranium-235 is one of the more easily fissionable isotopes. So nuclear power plants will harness kinetic energy from 3 neutrons to produce a self-sustaining chain reaction of nuclear fission. So a light water reactor is the only type of reactor used in the United States and is the most common type used around the world. Another component of this reaction is a fuel rod, and it's a tube that encloses a nuclear fuel with a nuclear reactor. And nuclear fission rates have to be controlled so that reactions don't happen quickly. This can be done by a control rod, which is a device that can be inserted between the fuel rods to absorb excess neutrons, thus slowing or stopping fission. And this can also be done routinely to prevent meltdown or fire. And meltdown is when nuclear rods are left uncontrolled and will quickly become too hot and melt. So some advantages and disadvantages to nuclear energy. Some advantages are it does not produce air pollution during its operations. And one way you can achieve independence from imported oil is it's cheap when it first started being used. And some disadvantages are it does use fossil fuels to mine. The process and transportation of nuclear fuel and construction of power plants is very expensive, and the overall process is very expensive politically and economically to build power plants. And environmental concerns with the possibility of accidents and how to properly dispose of the radioactive waste that it produces. So one of the major cons is the possibility of accidents, and there have been a couple accidents recently. One of them happened in the 1970s, and it was a partial meltdown of a plant in the 3 Mile Island in Pennsylvania. And then a big meltdown happened in Ukraine in the 1980s, and many plant workers and firefighters died, and there were additional cancer deaths in the area. It contaminated crops, and milk from cows from grazing grass was also contaminated because of this leak of radioactive waste. So this is just an example of an accident that had a big impact, actually a very devastating impact on a community. And the picture down there shows an orphanage, and all these when it happened, all the children and the workers had to flee, and so you can see the destruction that it just did to the furniture, and these people also were also harmed because of this accident. So radioactive waste specifically is the nuclear fuel that can no longer produce enough heat to be useful in a power plant, but continues to emit radioactivity. And so this means that it has to be stored in special, highly secured locations because it can be extremely damaging to living organisms. So some types of radioactive waste are 1, high-level waste. It's used in fuel rods. 2, low-level waste, contaminated protective clothing, tools, rags, and other items used in routine plant maintenance. And 3, uranium mine tailings. and its residue left after a uranium ore is mined and enriched. So a BQ measures the rate at which a sample of radioactive material decays. So 1 BQ decay is equal to 1 atom per second. And a Curie is another measurement for radiation. So 1 Curie equals 37 billion decays per second. And spent fuel rods remain dangerous to humans for 10 or more half-lives. And today, nuclear plants are required to store more spent rods at the power plant, some in water and some in lead-lined dry containers. As you know, disposing of nuclear waste is very difficult because it cannot be incinerated, safely destroyed using chemicals, shot into space, dumped in an ocean, or buried in an ocean trench, because they all involve the potential for large amounts of radioactivity to enter the atmosphere or oceans. And we have to make sure that this doesn't leach into groundwater or escape into the environment, and it has to be far from human habitation in case of accidents. So last slide is on fusion power. So nuclear fusion is a reaction that powers the sun and other stars, and it occurs when lighter nuclei are forced together to produce heavier nuclei. So lots of heat is generated during this process, and it's most promising for electricity generation, because 2 hydrogen isotopes fusing into a helium atom release a large amount of energy and a relatively small mass is lost. So some pros for this is that it requires only hydrogen as an input and produces a relatively small radioactive waste. And a con is the need to heat material up to 10 times the temperature of the core of the sun to create fusion, and these temperatures are very hard to contain.